Okay, so let's take a look at assignment 1 and see if we can go through the solutions. So our first problem is summations and products, and the first is a sum. So we want to calculate the sum from I equals 0 to I equals 4 of 3 to the I. And this is the same as 3 to the 0 plus 3 to the first power, where I equals 1, plus 3 squared, plus 3 cubed, plus 3 to the 4th. And so this is the same as 1 plus 3 plus 9 plus 27 plus that times 3 is so 81. And we can add those all up. We get 4 plus 9 is 13, becomes 40, 121. Okay, so the next problem is a product. And so it's the product j equals 3 to j equals 7 of -1 to the j. So the first piece is -1 cubed times -1 to the 4th times -1 to the 5th times -1 to the 6th times -1 to the 7th power. But -1 cubed is -1 times -1 times -1. And when the parity is odd, we'll see that's -1. But -1 to the 4th, that's just +1, because -1 times -1 is positive. Do that twice, you get back to positive. -1 to the 5th is negative. -1 to the 6th is positive. And -1 to the 7th is negative. And so if we take a look, we've got 1, 2, 3 negatives, which is a negative. And so our final product is -1. The next question we have is a sum, a summation from I equals 0 to I equals 4 of 3 times I plus 2 to the ith power. And that means we're going to add up 3 times 0 plus 2 to the 0 plus 3 times 1 plus 2 to the first power plus 3 times 2 plus 2 squared plus 3 times 3 plus 2 cubed plus 3 times 4 plus 2 to the 4th. So now we need to put all that together, and that's just 0 plus 1 for that first piece, plus 3 plus 2 for the second, when I was equal to 1, plus 6 plus 4 plus 9 plus 2 cubed, which is 8, plus 12 plus 16. So that's 1 plus 5, let's take care of that, plus 10 right there, and this is a 17 plus 28. We can add those all up. 1 plus 5 is 6, plus 10 is 16, plus 17 is 33, 61. There we go. And of course you can do a quick check on your calculator if you want, but I think we've got it. Great. Okay, so the next question then, the final question is the sum, the nested sum, I equals 1, 5, j is equal to 0, all the way up to j is equal to 3 of I plus 2j. And so we're going to handle the inside first. Going to leave this outside alone, I equals 1 to 5. I'm going to, because we can think of this really as the inner sum we can do first. Just as in nested loops, we do the inner loop first. And so we're going to leave I as I, and I'm going to figure out what should exist within that inner bracket. And so we get I plus 2 times 0 when j is equal to 0. When j is equal to 1, we get I plus 2 times 1 plus I plus 2 times 2 plus I plus 2 times 3 when j is equal to 3. And so we can break that down a bit further. We'll leave this as I equals 1 to 5. And then we'll see that this is the same as I plus 0 plus I plus 2 plus I plus 4 plus I plus 6. And we can combine those terms. So we really have a sum, I equals 1 to 5 of 1, 2, 3, 4I plus, there's 0, 2, 6, 12. But we can break that down, right? And in fact, what we see is we're just going to add up 12, 1, 2, 3, 4, 5 times. So this is going to be the sum of 4 times 1 plus 4 times 2 plus 4 times 3 plus 4 times 4 plus 4 times 5 plus 5 12s. That's going to be in there 5 times on its own. And what that means is we get 4 plus 8 plus 12 plus 16 plus 20 plus, and then those 12s plus 60. And what that gives us, if we add it all up, let's see, we've got 4 plus 8 is 12, plus another 12 is 24, plus 16 gives us 40, plus 20 is 60, so we end up with 120 once we add the 60 in. Okay, and that's it for problem 1.